In our last video, we took a look at HSRP operation and troubleshooting. Now it's time to take a look at VRRP. And the great news is we're going to use many of the same troubleshooting approaches. We want to gather similar information when we're troubleshooting VRRP. The terminology is a bit different. Remember, with HSRP, we had an active router and a standby router, each of which could service the IP address and the MAC address of a virtual router. In this case, instead of calling it an active router with VRRP, when PC1 points to the virtual router's IP address, the router or the multilayer switch that's going to be forwarding that packet, instead of calling it the active router, we call it the master router. This is the virtual router master. And instead of having a standby router or multilayer switch, we've got one that's in a backup state. But similar to HSRP, if we did lose SW2 for some reason, it had issues, then the backup would transition to the master, and PC1 could use SW3 in this topology to get out to the internet. And we talked about how HSRP sent a hello message every 3 seconds, and if the standby router did not hear a hello message from the active router within the whole time, which defaulted to 10 seconds, then that standby router started to transition to the active state. Well, here with VRRP, similar to a hello message, there's going to be an advertisement sent, and it defaults to 1 second. And instead of having a hold time like HSRP did, VRRP has something called the master down interval. If we've not heard an advertisement for that period of time, then the backup can transition to the master state. And even though there are a lot of similarities between VRRP and HSRP, it's not really like comparing apples and oranges, I did want to take a moment and contrast the two. HSRP is Cisco proprietary, while VRRP is standards-based. And this means if we're working in a mixed vendor environment, we might opt for VRRP. And you see the RFCs on screen which describe the operation of these two first-hop redundancy protocols. We talked about the terminology differences. Instead of having an active router, we have a master router with VRRP. Instead of a standby router, it's a backup router. And the virtual MAC address used by HSRP can vary based on the HSRP version number. Notice for version 1, we've got 4 zeros and a dot and a 0C07.AC. And the last 2 hexadecimal digits, we put the HSRP group number in hex in those 2 digits. With HSRP version 2, notice we've got 3 X's. We could represent a larger number for our HSRP group. And you see in this table the MAC address used by VRRP. We talked about the preempt option with HSRP that let a router get its old job back. If it went down and came back up and it had a higher priority, it could take back over the active role. But that preempt feature was not enabled by default with HSRP. It is enabled by default with VRRP. The default hello interval was 3 seconds for HSRP, but the master advertisement interval is only 1 second for VRRP, and the default hold time with HSRP, the time after which we say, hey, I haven't heard a hello message from the active router, I guess I need to transition from standby to active, that's 10 seconds by default with HSRP. It's a bit more complex with VRRP, however. Instead of having a hold time, the router is going to calculate a master down interval. What it does is multiply the master advertisement interval by 3. We've got a default master advertisement interval of 1 second. Well, we multiply that by 3, giving us 3 seconds, but in addition to that, we add on something called the skew time. The skew time is a function of the VRRP group priority value. We take 256 and subtract the priority value of the VRRP group. We take that number and divide by 256. That's our skew time, and we add the skew time again to 3 times the master advertisement interval. Both HSRP and VRRP communicate using multicasts, and this table shows us those multicast group addresses. And one other interesting distinction is that with HSRP, the virtual IP address that we're servicing, it cannot be the IP address of an actual router interface. However, with VRRP, it can be. It's not considered a best practice, but if we wanted to for some reason, we absolutely could have the virtual IP address be the IP address of one of the router interfaces. When it comes to troubleshooting, we've got a similar set of things we're looking for when we're troubleshooting VRRP. For example, we want to identify who is the virtual router master and what is the virtual IP address that we're servicing with this VRRP group. What about the virtual MAC address? And just like we did with HSRP, let's check preemption and tracking, remembering that preemption is enabled by default with VRRP. Using this topology on screen, let's take a look at a couple of show commands we can use to gather information about VRRP for verification or troubleshooting. And the first command I want to show you is similar to what we saw with HSRP. Remember, we could do the show standby brief command? Well, we could do a show VRRP brief command here. And it tells us things like our priority, it's 110. It says that preemption is enabled. The Y says, yes, we're enabled for preemption. Our state is the master. We are the virtual router master. And the master address is us, 10.1.1.2. Here's the group address. In other words, this is the IP address that we're servicing, which could be, it's not in this case, but it could be the IP address of our interface. If we want more information, we can say show VRRP. And this is going to tell us information such as our state, we're the master currently, the virtual IP address, and information we did not get with the brief option. It's going to show us the virtual MAC address that we're servicing. We also see that we're using the default advertisement interval of 1 second. Preemption is enabled. Our priority is set to 110, and we are configured with a tracking object, but the state is up. If it were not up, we would decrement our configured value of 110 by 20, but currently it's up, so we do have a priority of 110. The master router is us with a priority of 110. And again, we see that advertisement interval of 1 second. But notice the master down interval. How did the router come up with 3.570 seconds? Well, remember, it's 3 times the master advertisement interval, which is 3 times 1 or 3 seconds, plus the skew time. The skew time is 256 minus the priority, and we take that value and divide by 256. And as we're doing our troubleshooting, we would not want to stop here. We might go to R1 and say, oh, we're the master. Okay, that's solved. That doesn't explain my issue, but at least R1 is the master. I know that. Well, maybe if we go to R2, if those two routers are not communicating with one another, R2 might think it's the master. So let's give a similar set of commands on R2. Let's do a show VRRP brief command. And in this case, we do know that our state is backup. We are enabled for preemption. Here's the address of the master. That's R1. Here's the virtual IP address. And if we just say show VRRP without the brief, we get some additional information, including virtual MAC address information. And something else interesting to note, the master down interval is a little bit different here. Why is it a different value on R2? Because the priority is different. We've got a priority of 100 on this router. It was 110 on R1. And when we calculate the skew time, those values are going to be a little bit different because skew time is a function of priority. And that's a look at how we can gather some troubleshooting information for VRRP.